Hello, future engineers. Welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends, to your younger brothers and sisters who would want to take up engineering in the future, and to your relatives. That's one way you can keep me going, inspired, and refreshed. Now, if you find my videos interesting and important to your studies, also please don't forget to subscribe. Hello, viewers, subscribers, students, and future engineers. Here are another sample problem videos on about variations. Though the problems here are light, then it can help you improve your thinking skills in mathematics. Of course, you have to start with light ones. Then you have to increase the intensity, the degree of difficulty as we move on. If you want to anticipate the solution to these problems, you may do so by pausing the video, covering the solution, and just solving the problems right away. So for problem 6, the daily payroll for a work crew is directly proportional to the number of workers. And a crew of 12 workers earns a payroll of 32,400 Philippine pesos. Express the number of Philippine pesos in the daily payroll as a function of the number of workers. What is the daily payroll for a crew of 15 workers? So for part A, we have to derive the formula first. Daily payroll P is equal to constant of proportionality times the number of workers. I just call it W, or you may call it N. Then for a crew of 12 workers, they earn daily amount they earn a payroll of 32,400. So 32,400 equals K times 12. So K is 2,700 pesos per worker. So therefore, the formula is 2,700 W. So for part B, what is the daily payroll for a crew of 15 workers? So 2,700 times 16. So it is 40,500 pesos. Problem 7. The weight of a body is inversely proportional to the square of its distance from the center of the Earth. Given that a body weighs 200 pounds on Earth's surface, express the number of pounds in its weight as a function of the number of miles from the center of the Earth. The radius of the Earth is 3,956 miles. Then B, determine the lighter and the heavier weight of the body if positioned 400 miles from the Earth's surface. So the lighter is one that is farther from the center of the Earth. So it is radius plus 400, the distance. And the heavier is closer to the center, and that is radius minus 400. So the formula weight is inversely proportional to the square of distance from the center of the Earth. So weight equals K over distance square. So 200, this is the condition. The body weighs 200 on Earth's surface, so the distance is radius. So 200 equals K over 3959 square. So K is 3.135 times 10 to the 9 pound miles square, because this is pounds and distance is miles, so pound mile square. Formula therefore is weight equals 3.135 times 10 to the 9 over distance square. So for 7B, then weight, the lighter weight is one that is above the Earth's surface, so farther from the center of the Earth. So 3.135 times 10 to the 9, the constant, over distance radius plus 400 square. So the lighter weight is 165 pounds of the body, and the heavier weight is 3.135 times 10 to the 9 divided by quantity radius 3959 minus 400 squared, the one that is closer to the center of the earth. So the heavier weight is 247.5 pounds. Problem 8. In a small town of population 5,000, the rate of growth of an epidemic, the rate of change of the number of infected persons, is jointly proportional to the number of people infected and the number of people who are not infected. So in calculus, that's the rate of the spread or growth of the epidemic with respect to time, rate of change of the growth rate of epidemic. So dE over dt, but I will just call it function of P, and it is mentioned here it is jointly proportional to the number of people infected. So P is the number of people infected, and since the population is 5,000, the the number of people who are not infected would be total population 5,000 minus the number of people infected P. So that's the formula. And for the first question, given that the epidemic is growing at the rate of 9 people per day, rate of change of growth of epidemic 9 people per day, when there are 100 people infected, express the rate of growth of the epidemic as a function of the number of people infected. So let's solve for the constant. 9 equals constant people infected 100, then not infected 5,000 minus 100. Solving for k is 9 over 490,000. So that's the constant of proportionality. Therefore, the formula for Fp or dEdt is 9 over 490,000 K times P 5,000 minus P. So that's the formula. Then for part B, how fast is the epidemic growing when 200 people are infected? So substitute 9 times 200 over 490,000, quantity 5,000 minus 200. So that would be 17.63 people or persons per day. So that's the answer to part B. Problem 9. The maximum number of bacteria supported by a particular environment is 900,000. And the rate of bacteria growth is jointly proportional to the number present and the difference between 900,000 and the number present. So that's almost the same as the top, as problem 8. So let f of x bacteria per minute be the rate of growth when there are x bacteria present. Write an expression defining f of x. Then b, what is the domain of the function f in part A? So the formula is f of x is proportional, jointly proportional to the number present, so that is denoted with x, and the difference between 900,000 and the number present, so 900,000 minus x. So that's the formula in general. Then what is the domain of the function? The domain of the function is 0. There may be no infected to the total population, which is 900,000. So that's the domain of the function. Then let's continue. Problem 10. Express the statements in A to D as equations. A varies directly as B squared, U varies inversely as T. So A varies directly as B squared. So A equals constant, then times B squared. U varies inversely as T. So U equals constant over T. S varies jointly as U and T cubed. So S is constant K, U times T cube. Then 10D, W varies directly as U and inversely as the square of V. So W equals KU over V square. So I hope that you understood. That's very simple. 11. Part A, if Y varies as X and is 10 when X is 5, find the value of Y when X is 7. So the formula Y equals Kx. So solving for K because K is not important here. So Y over X equals Y1 over X1. This is the initial condition. This is the final condition. So find Y when X is 7. So Y over 7. Then in the initial statement, if Y is 10 when X is 5, so 10 over 5. Solving for Y is 7 times 10 over 5, and that is 14. 11b, given that Y varies inversely as X, so Y is K over X. If Y is 3 when X is 4, find the value of Y when X is 6. So K therefore is XY equated to X1, Y1. So find Y when X is 6, so 6 times Y, then equals 4 times 3, initial condition. Solving for y is 2. Then lastly, problem 12, part A, given that x varies jointly as w and y, and also that x is 24 when w is 3 and y is 4, find the value of x if w is 4 and y is 5. So the formula x is constant of proportionality times wy. So solving for k, x over wy, then equate into x1 over y1 over w1 y1. So in the last condition, find the value of w when x is, find the value of x when if w is 4 and y is 5. So x unknown, w4, y is 5. Then in the initial condition, x is 24 when w is 3 and y is 4. W3, y is 4, cancel 4. So x is 24 times 5 divided by 3, that would be 40. 12b, given that w varies directly as the product of x and y and inversely as the square of z. So the formula w equals kxy over z square. K therefore is wz square over xy, and that is w1 z1 square over x1 y1. So if w is 9 when x is 6, y is 27, and z is 3, initial, find the value of w when x is 4, y is 7, and z is 2. So w unknown, z is 2, so 2 square over xy. X is 4, y is 7, equals, initial condition, w is 9, z is 3, so times 3 square over x6, y 27. So we cancel 27 and 9. There is still 3 here, but because of that 3 square, so we also cancel 27, 9 times 3. There is still 3 to the 1 or 3. So W is, we also cancel 2 square and 4. So W is 7 times 3, 21 divided by 6. 21 divided by 6 is 7 halves. So W is 7 halves. And 12C, the volume of a right circular cylinder varies jointly as the height and the square of its radius. If the volume of a right circular cylinder of radius 4 inches and height 7 inches is 352 cubic inches, find the volume of another of radius 8 inches and height 14 inches. Formula, volume varies directly, so equals constant of proportionality to the altitude, height, and the square of the radius. So that's the formula. Therefore, volume, solving for K, volume over R square H equals V1 over R1 square H1. So find the volume of another 8 if the radius is 8 square, then height 14. Then in the initial condition, the volume is 352. When the altitude is 4, height is 4, so 4 square, then radius 4, 4 square, height 7. So solving for V, 352 times 8 square times 14 divided by 4 square times 7, you will get 2816 cubic inches. So that's it for this problem. I hope that you were able to follow the explanations and the solutions. And for those who attempted to solve this problem, I hope that you got the problems perfectly.